Hello everyone, in this video we'll see binary searching algorithm. Binary searching algorithm is a very basic and fundamental algorithm in searching algorithm categories. Before getting into the binary search algorithm, we'll see what is searching. Searching is we are looking for a number or some string or anything else in an array. So in schools and colleges we would have learned if we want to search a number in an array, we will just write one for loop and we'll go element at index 1 2 3 4 5 6 7 and in that way we'll find out whether the element is there or not. But when the array comes up with some of the properties built in with this, we can use some advanced methodologies to search it. See, here I have one array. This array carries these following properties. It is a sorted array. You can see this number is gradually increasing, and it is an one-dimensional array and it's a numeric array. But this one is binary search algorithm is applicable for 2D arrays also, and non-numerical arrays also. It can be either positive or negative. It can be numbers, anything we can use it. But that's goes beyond the scope of this tutorial. So we'll just see what's the binary searches. Here binary means two numbers. That's binary. You have to see bi means two. So with help of two numbers, we are trying to find out a number, trying to search a number. So like this, ternary search are there. You see n-ary search, n number of searches are there. There are a lot of searching algorithms are there. But binary searching is a very fundamental algorithm. Okay, how do we perform this binary search? We have an array which is a sorted array. If it is not sorted array, you can feel free to sort it. At most it will take n log n algorithms are there, so you can use those algorithms and you can sort it. So with this help of a sorted array, you're going to find out an element called x. So whether this 90 is there in this, we'll just iterate through this and then we'll find out, yeah, this 90 is there. So we'll print that as yes, we got this. Instead of those conventional methods, what we are doing is we need to understand some realizations, some facts with this array. See, when I get this element like 90 or 100, if I'm seeing 100, the 90 will fall below 100. So I no need to consider this 225 at all. When we are searching the linear search itself, once you get that number, you will break it. If it is a sorted array, if you're going one by one, once you find out this element called 90, definitely you will break it. You will write if condition, and once you find out, you print that element found and break it. Like that, we need to understand something here. So when I'm seeing for 40, when I'm looking for 40 or I'm seeing I'm considering only these four elements like 40, 70, 90, 100. In this, if it is a sorted array, definitely the numbers will be lesser than 40, these numbers. So I no need to search here. So we need to understand these kind of facts in a binary search. So and we'll write the algorithm. So okay, how to write this algorithm? This algorithm is the indexed based algorithms. So we have this array, means here you will have corresponding index. We have for 9 it will at first position, 20 at second, but it starts from 0. So I have given this one in 0 indexed based. So 0 to 6 are there. So I have 6 elements. So I told you, I'm reminding you again and again, should be a sorted array. If it is not sorted, it will not work. So it must be a sorted and prior. So it's already sorted, that's I can guarantee. The input order is sorted array. And index, I'm saying I'm keeping the first index and last index. I know the last index is nothing but the size of that -1. That's it. So what I'm doing is I'm finding a middle position of it. Middle position, how do I find it? Mid equals, here I have indicated this red as low and green as high, which means the low will be initialized to 0 and high will be initialized to 6. This number will be in this array pointer. So what I'm doing is low plus high. The median is nothing but a formula. A formula for median is we have to find two numbers, like what is the middle number of this from 0 to 6. What is the middle number? That's what we have to find. So what I'm doing is I'm just increasing this, low plus high and then divided by 2. This is the median. Mid is nothing but low plus high divided by 2. But when you are considering this median, when this low and high are in case very large number, you will go into a trouble called array index out of bound or integer overflows. Instead of that, what I'm doing is I'm transforming this formula as high minus low divided by 2. This equation is literally same because if you subtract, this 2 will come for this one and for low also, and then their off lows will be cancelled. So finally what will result is low plus high divided by 2 only. This is literally same, and first statement is best for programming because you will face integer overflows like that and all. So using this formula, I'll apply this, and how do I compare this? So here I have the position 0 and 6. I'm taking these two positions 0 and 6. This is lower and this is higher. So what I do is I'm keep moving this one here. I have one more. So mid equals, now I'm picking this low. I have already initialized to this one to 0, this one to 6. So 0 plus 6 divided by 2. 0 plus 6 divided by 2. So what the answer will be is, this 3. So we are checking the middle number of we will take this in our index 3. This will gives equals 3. So what the result is, I'm going here. So I know this is a sorted array, and I'm checking this array of 3. What is this number? So that number is literally 70. So I pick this number. So I have this index. I know this what index carries. We can just simply write array of 3, that is 70. You can consider this as an arrow mark. This is not that equals or greater symbol. This is just an arrow mark. So I know this 70, and I'm comparing this with my x. So is it greater or lesser? So is it greater or lesser means it is lesser. You are comparing that ARR of, instead of this 3, I'm giving as mid, and I'm checking x, that means that 90. So this x, is it lesser? So I'm just applying this one. Here array of mid, what I got is 70, x is 90. So is this true? Yes, it is true. It is. So this element itself, what we looking for is lesser. So obviously these elements we no need to consider at all. These three elements we no need to consider at all. So we have this 3. So the lower pointer I'm just shifting this to this 3. Okay, so the low will be, so this element we know it's 70 itself is not there. Obviously we have to switch to the next element, not this element itself. If we just find here itself, we'll return. So obviously it will be the next element in this case, or else when the case it goes beyond that one, we will reduce. So it will be low equals to mid plus 1. Hope you understood this one. How do we write this algorithm is, I'll walk through one more time after this. Okay, now it is low mid 1. Here it comes, and when next iteration goes, we'll find this one. Wait. Okay, in next iteration I have this low as mid plus 1. So it's my low is standing at 4. The next calculation, how do I do is, here I have the same formula for calculating the mid, equals to 4 plus 6 divided by 2. This divided by is for both, not only for this one. So what I have is, it's 10. So 10 divided by 2, what the answer I'll get is 5. So I'll get 5, mid equal to 5, equals 5. Okay, now I'm checking mid of 5. Mid of 5 is nothing but ARR of 5. ARR of 5 is what? 100. So ARR of 5, is 100. So I'm comparing this one against my 90. So is this possible? This is wrong. So my algorithm is, this pointer should reduce its position. So what I'm writing is, my algorithm changes to, it's applicable to, this condition is false. Always I have to apply this condition, that array of mid less than or x. So I'm giving as high equals to mid. We know this is itself is wrong. So what, 5 itself is wrong. So I have to reduce that number. So -1. So whenever the low comes, you have to give mid plus 1. Whenever high comes, you have to give mid -1. So mid plus 1 is nothing but 4, and high also, this is at this position. It may overlap. So okay, now next time I'm seeing, for next iteration I'm checking. So now I'm calculating the mid. So low and high both are same. That's 4 plus 4 divided by 2. That gives me the same answer. So its mid is 4. I'm checking the ARR of 4. That's nothing but my element, that's 90. But whenever I'm finding out this divided by, you have to check this, you got this element or not. ARR of mid equal to that x, you have to check, and then if it found in that, you have to return it. That you have to make sure that's working fine. So like this we found out the element 90. This is what the whole algorithm is. The algorithm, you need to realize some facts, that whenever you got these elements, you have to check that sorted properties. So we have to use that. and you have to write the algorithm. So the same thing we'll interpret into the code. Here I have one element int c, which means the count. So enter count, and I'm getting those elements in one array, and then now I'm going to write my function. Bin searching. I need that array reference first of all, so int arr, and then I need the size of that array, so I give int c. I need two pointers. That pointer is, you no need to think much, it's nothing but a variable, so int low comma high. Here the low is first the 0 and high is c minus 1, because this is 0 based. So I need to continue the process until this element, which means this is not a possible condition, because here you can see high points to 3 and low points to 4. This condition is wrong. So I need to perform this operation until this, at most it is in same position. I should not cross this point, because you can consider this scenario, it's not at all possible, right? When high pointer is pointing to lower number and low pointer is pointing to high number, it will be like continuously it will be going. So at most it can be like it's in the same position. So that's the reason. Okay, now let me move back to the IDE and code for this. I have high and low declared, and I have to perform this task until it overlaps. So high greater than or equal to low. After this condition, it's not possible, right? High should be lower or low should be higher. And I write the edge condition also. If it is not at all there, I have to return -1. So now I'm calculating the mid. So mid equals, so low plus then high minus low divided by 2. Now I'm checking for this element whether mid stands for my array element or not, arr. Here I have to declare this arr of mid equal to x. X is nothing but the elements needs to be found. So if I found this, I have to return 1 as a success message. If it is not there, I have to proceed with the algorithm. This is just to figure out whether this current mid stands for that element or not. So I'm writing if this arr of mid, array of mid less than x. If it is less than x, we have to completely ignore the lower part. Ignoring in sense, we are just advances that mid to +1 and assigning it to the low, or else I have to write this else as high equals mid -1. Here sometimes you will get confusion whether we have to mid or mid -1. This one and here the equals matters. So if you're subtracting here -1, this equal to must be there. If it is only just mid, that equals to no need to be there. So this is just one line. I'm just removing these all braces. So this itself is enough. Now I'm running the code. Before running, I have to declare this. So here cout, I'm calling the function as bin searching. I'm declaring this line as pointing the array and the total size of the array, and the elements need to find is 90. So my code is ready to run. I'll just clear the terminal and run. Enter the count. I copy my text data, enter. It returns 1. 1 means it's available. So I can make a ternary condition here. Exist now. Run code. Greater than 0. Run code. Exist. So I'm passing number 80. Right click, run code. Now, okay. I hope you understood all those functionalities of bin searching and why this made, and how this pointer is moving here and there and all. This prior condition must match. It should be a sorted array, 1D array or 2D array, that's not at all a matter, but it should be an array. And numeric interpretation is essential for this, but you can apply that with hash, and you can convert to a number, and then that converted number can be a sorted array, and then you can apply this algorithm. So before you're just coding for this algorithm, make sure you're using sorted array, or else you can use the sort functions in C++ itself. You can use sort and then pass the array size. Okay, thank you everyone, and thank you for watching.